Good morning. Okay, today we're going to be talking about geometric sequences. Today we're going to be doing the first day, and the next lesson I have for you will be the second and last day, which will be either pictures and or word problem kind of lesson. So let's take a look at this one. So it says, what if my change is not constant? Okay, so we did sequences way back when in the fall when we were doing linear functions. We did arithmetic sequences, which I'm going to remind you about them today when we go over this. So today we're doing geometric sequences, which go hand in hand with exponential functions. Okay, so once I do this lesson and my next lesson, I'm finishing out function families and exponential functions, and then I'm moving on to our last unit, which is statistics. Okay, so let's take a look at this. So we're going to look at the sequence, and this one says 2, 6, 18, 54, 162. First, we're going to identify the first term. So the first term is how the sequence starts, and that's going to be 2. We're trying to look for a pattern to see how we go from the first number to the next number to the next number to the next number. You always look at the number in front of it, the previous term. So how do I get from 2 to 6? How do I get from 6 to 18? How do I get from 18 to 54? How do I get from 54 to 162? So basically, I'm timesing by 3. Hopefully you see that. What would the next term be? So I'm going to use my calculator and I'm going to multiply 162 times 3. And I got 486 would be my next term. Okay, let's take a look at the next one. 3, 5, 7, 9, and 11. The first term is 3. How do I go from 3 to 5 and 5 to 7 and 7 to 9 and 9 to 11? I'm not timesing this time. This time I am adding 2. So if I'm going to add 2 to this last term here, 11, if I add 2, my next term will be 13. Okay. Let's take a look at the next one. 3, 11, 19, 27, 35. Okay, the first term of this sequence is a 3. How do I get from 3 to 11, 11 to 19, 19 to 27, and 27 to 35? I believe I am adding 8. If that is the case, what's 35 plus 8? I would get 43. Okay, let's try this cool color. 2 9ths, 2 3rds, 2, 6, and 18. So how do I get from 2 9ths to 2 3rds? How do I get from 2 3rds to 2? How do I get from 2 to 6 and from 6 to 18? So I can really see it a little bit better here, but it does actually work here. The first term is 2 9ths. I am timesing by 3. 2 9ths times 3 actually gives me 6 9ths, which in lowest terms is 2 3rds. If I take 2 3rds and I times it by 3, I would get 2. 2 times 3 is 6, and 6 times 3 is 18. 18 times 3 gives me 54. Okay. How about letter E? 4, 2, 1.5, 0.25. So it looks like I'm dividing by 2. So a lot of people think that you're dividing by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is a half. I agree. So, but there's another way of saying it, and we really want to keep it in the times or adding. So instead of saying divided by 2, I'm going to say times a half. I'm going to put that here. The first term, by the way, was 4. And then if I put 0.25 and I times it by a half, I would get 0.125, or if I want to leave that as a fraction, it would be 1/8. Doesn't really matter. I'm good with either. Okay, so as you can see, some of these sequences are adding and some of them are times. So the ones that we're adding, we actually did those. Those were called arithmetic sequences. That's what we did this concept way back when we did linear functions. An arithmetic sequence is a sequence of numbers which increases or decreases by a constant amount each term. D is the common difference. And these look like linear functions. So for example, I'm going to go backwards for a second. So like the D in this example is 2, and the D in this example is 8. If you told me the difference was that they were subtracting 3, the D would be -3. Okay? This was the explicit formula that you guys learned. It's on your formula sheet, and we always give it to you. And I think if you remember correctly, the D, I recommended that you write it in the front because it was easier to distribute and to solve and whatever. A sub n is just the nth term in the sequence. A sub 1 is the first term in the sequence. N is the number of terms in the sequence. It could be like the 8th term, the 10th term, n would be 8 or n would be 10. So geometric sequence is the new one. That's the one we haven't done yet. That's this guy down here. And that's basically not if you're adding. A geometric sequence is a sequence of numbers that follows a pattern where the next term is found by multiplying by a constant ratio. So it's not called a difference anymore. It's called a ratio. And that's R. R is the common ratio. Geometric sequences form exponential functions. So they're going to look like either going like this or like that. And then here is the formula that you will be given and that you will be using each time. So it's A sub n, or the nth term in the sequence, last term in the sequence, is equal to A sub 1, which is the first term, times the common ratio, whatever that is, to the n minus 1 power. So this power is what makes it exponential. All right, so let's take a look at some examples. Determine if the sequence is geometric, arithmetic, or neither. So basically, we're going to just look at them, and we're going to come up with a decision, and then we're going to write down a word. So how do you get from 1 to 5, and 5 to 25, and 25 to 125? So hopefully you're saying times 5. And if I'm timesing, it means it's a geometric sequence. Okay. How about the next one? 40 to 43 to 46 to 49. So I am adding 3, which makes it an arithmetic sequence. How do you get from -3 to positive 15, from positive 15 to -75, from -75 to 375? So you could think they might be adding, but then it's alternating signs. It's alternating signs, that's going to lead me to believe that I'm timesing by something, and probably something that's negative, because a negative times a negative is a positive, positive times a negative is a negative. How do you get from -3 to positive 15? How would you get from 15 to -75? I'm going to times it by a negative number. Anybody know what negative number that is? I think it's times by -5. And if you're not sure, you can actually play around with it. You could guess and check. You could do some dividing to sort of see what's it going to be. But if I'm timesing by something again, it's going to be a geometric sequence. Okay, let's try the next one. How do you get from -2 to -4 to -8 to -16? So am I adding -2? Well, that works there, but it doesn't work between -4 and -8. If I add -2 to -4, I get -6. So that didn't really work. How else can I get from -2 to -4? I could multiply it. I could times by 2. So signs are all negative. So I'm going to say times by 2, which that works for all of them. Since I am multiplying, it's still considered geometric. -1 to -6 to -11 to -16. So I am not timesing to do this because it doesn't work from -6 to -11. So let's see, could I be adding or subtracting? Take either. I'm going to go add -5. I could be subtracting 5, but I like to use the words add and times. So this makes this an arithmetic sequence. All right, last one. How do you get from 54 to 27? 54 to 27 to 9 to 3 to 1. So again, some of you might be thinking you're dividing by 3. So we're not going to be using the word divide or subtract. If you see here, I'm adding a negative number. So instead of dividing by 3, I'm going to write it a little differently. I'm going to write times 1/3. 54 times a third is 27. 27 times a third is 9. 9 times a third is 3. 3 times 1/3 is 1. Still considered geometric. Still timesing. Okay, so hopefully you know the difference between geometric and arithmetic and you understand how to do that. Okay, these numbers that I have here, the 5, the -5, the 2, and the 1/3, those are considered my R's or my ratios. Okay, when I'm adding these numbers over here, adding this and adding that, those are considered my D's or my common difference, as we learned earlier. So let's take a look. So we're given the first term and the common ratio of a geometric sequence. Find the first 5 terms and write the explicit formula. Okay, so there's a lot going on here. So first they're giving me the first term. So I'm going to write the first term in the first spot. Oops. So I'm going to write 1 because it tells me the first term is 1. It tells me that the common ratio is 2, and if it's a geometric sequence, then it means that I am timesing by this number. So if I times this by 2, I get 2. If I times 2 by 2, I get 4. If I times 4 by 2, I get 8. If I times 8 by 2, I get 16. So this is my sequence. So now you're kind of doing the reverse of what we did before. I gave you the sequence and then you had to figure out what was happening. So this is 1, 2, 4, 8, 16, ... The explicit formula comes from this formula, which you will always be given. So it's going to be A sub n equals, the first term in this case is 1. The R you were told was 2. And I'm raising it to the n minus 1 power. So we're just going to copy that. And this is what's called the explicit formula. Okay, let's try the next one. So A sub 1 is 0.2. My R is -5. So I'm going to use my calculator because I don't really know this. So I'm going to start with 0.2. And I'm multiplying because that's what the R tells me. And I'm going to times it by -5. And I get -1. Now I'm going to take that and times that by -5. And I get +5. Then I'm going to take this, times it by -5, and I'm going to get -25. And then I'm going to take that and times it by -5, and I get +125. So if you take a look at this, it's kind of interesting. The signs alternate, positive, negative, positive, negative, positive. If that ever happens, chances are you're going to realize that the R, or the common ratio, is always going to be a negative number. All right, so let's write the explicit formula. We're going to use this formula up above here, one little star. And I have A sub n equals, and the first term is 0.2. My R is -5, and I'm going to raise it to the n minus 1 power. Okay, let's try the next one. The first term is 2. The R is 5, so I'm going to times the prior term by 5. So 2 times 5 is 10. 10 times 5 is 50. 50 times 5 is 250. 250 times 5 is 1250. It's a big number. Okay, let's write the explicit formula. A sub n equals, who's the first term? 2. Who's my R? 5 to the n minus 1 power. Okay, let's keep going with this. So there's a few more that we're going to do just like we were doing. There's different things going on here, but that's okay. Okay, we're going to keep writing the first 5 terms, and we're going to write the explicit formula. So here it tells me that the first term is -3. It's telling me that I'm going to times that by -3. So now that I'm timesing by a negative number, which I'm noticing, I should have alternating signs. -3 times -3 is +9. That's good. 9 times -3, -27. Signs are alternating. -27 times -3, +81. 81 times negative 3, negative 243. Please use your calculator to help you get those terms. So the formula, in case you forgot from the prior page, is a sub n equals a sub 1 times r to the n minus 1 power. So I'm going to do that. A sub n equals, and I'm going to do, the first term is negative 3. My r is negative 3. Make sure you put that in parentheses, to the n minus 1 power. Okay, let's try the next one. First term is 20. R is to times it by a half. So what's 20 times a half? 10. 10 times a half? 5. 5 times a half? 5 halves, or 2.5. 5 halves times a half? 5 fourths. So you can write 2.5 here if this makes you happy. And I can write 1.25 here if that makes you happy too. The explicit formula, a sub n equals, the first term is 20, the r is a half, and I'm raising it to the n minus 1 power. All right, hopefully you're getting comfortable with all this now. The first term is 3/4. The r is, I'm going to times everything by 5. So I get 15/4. 75/4. 375/4. 1875/4. There's a lot going on there. So let's say you didn't want it, let's say you wrote it in decimals. So you wrote 3/4. So this is 3.75. This is 75/4 is 18.75. 325/4 is 93.75. And then the last one is 468.75. So I like the fractions. It's not really scaring me much, and I'm not a fraction person, but it's up to you what you want to do. A sub n equals, so the first term they said was 3/4. The r was 5 to the n minus 1 power. Okay, so hopefully you feel comfortable with explicit, and hopefully you feel comfortable generating the first 5 terms, and hopefully you know the difference between a geometric and an arithmetic sequence. These are all geometric that we're working with, and that we can see what the r does from the first term to the next. All right, so let's keep going. So let's take a look at the next section. So the next section kind of puts everything all together here. So I'm going to give you a sequence, and you're going to, all the sequences I'm giving you are geometric. So I'm not going to make them the difference between arithmetic and geometric. What you are going to do is you're going to determine what the r is. So how do you get from 3 to 30, from 30 to 300, from 300 to 3,000? What are we doing? So we are timesing, and what are we timesing by? That's the question. And if you're not sure, play around on your calculator. Either guess and check or start dividing 30 by 3, 300 by 30, 3,000 by 300. So hopefully you're saying you're timesing by 10. That's what my r is going to be. So my explicit formula is going to be a sub n equals, now I have to think about who the first term is. So the first term is 3, the r is 10, and it's raised to the n minus 1 power. So this is the kind of questions they like to ask you, though. I like to say to you, okay, so what's the 6th term in the sequence? So that's not such a terribly hard thing to figure out from here, because you could probably generate more numbers than this. But when they start to say to you, like, what's the 100th term or what's the 50th term, you're not going to plug and chug out to the 50th. It's going to take you too long. So instead, you're going to use this formula up here, and you're going to replace the n with this number. So I'm going to plug in 6 minus 1. And I'm going to do a sub n, or actually, it's not even a sub n. We are actually finding the 6th term. So we're doing a sub 6 equals 3 times 10, and it's going to be raised to the 5th power, because it's 6 minus 1 is is actually equal to 5. So now I'm going to go into my calculator and I'm going to plug in 3 parentheses 10 close parentheses caret 5, and I'm going to hit enter, and I'm going to look at my calculator and it's going to tell me that the sixth term is 300,000. And you can probably figure that out. If I took this and times this by 10, it'd be 30,000. Times that by 10 again, it'd be 300,000. So that one wasn't terribly hard, but you're going to learn to use this formula down here. Okay, so let's move on to the next one. 1, -4, 16, -64. So hopefully you see that it is definitely geometric. I'm multiplying by something. What are you timesing the prior term by to get to the new term? What is my R going to be? So again, the signs are alternating, so it's definitely going to be some sort of a negative number. What do I times 1 by to get to -4? Well, I times it by -4. And I think that that's what my R is. And if I tried it out for each one of them, it would actually hold true. So a sub n equals, my first term is 1. My R is -4 to the n minus 1. Okay, there's my explicit formula. What is the 8th term? So this is my n. So a sub 8 equals 1, -4 to the 8 minus 1. So technically, I am doing 1 times -4 to the 7th power. So I'm going to use my calculator and I'm going to figure that out, and I'm going to do 1 parentheses. I don't actually really even need that one, but I'm going to throw it in there for good measure. And I'm raising -4 to the 7th power, and I get -16,384. So I don't think it would be faster for you to sit here and times this by -4 8 times. I think it's just as fast or just as easy to plug it into the explicit formula, especially since they made you figure it out already. Okay, a sequence has an initial value of 7, and each term is 3 times the previous term. So it says write the first 5 terms of a sequence, because they didn't give that to you this time. So this is 7. And then it says to times it by 3. So 21, 63, 189, 567. So those are the numbers that I got. Hopefully you got the same as me. So what is R? 3. What is a sub 1? 7. What's my explicit formula? A sub n equals 7 parentheses 3 to the n minus 1. What is the 10th term of the sequence? So a sub 10 equals 7 times 3 to the 10 minus 1. A sub 10 equals 7 times 3 to the 9th power. So I have 137,781 is what I got. Okay, let's keep going. All right, so we're on to silver and gold, and then we're on to sum it up. So I'm going to do silver, sum it up, and then head back to gold. So let's take a look here. For silver, I gave you the sequence 2, -10, 50, -250. And I'm asking you, what am I timesing each by to go from one to the other? And again, if you notice, each of the signs is alternating. So I'm probably multiplying by some sort of negative number. What is that negative number? How do I get from 2 to -10 and -10 to 50? I'm timesing by -5. That's my R. My a sub 1 is 2. My explicit formula is a sub n equals, and then I'm going to do 2 times -5 to the n minus 1 power. Here they want me to find the 12th term. So I'm substituting in. 12 minus 1 is 11. So now I'm ready for my calculator. So I'm going to plug in 2 parentheses, -5, close parentheses, caret, and then an 11. And I get a big negative number. negative 976,56250. So negative 97,656,250 is the 12th term. Okay, let's sum it up, and then gold friends, I'm going to head back to you. So geometric sequences are exponential functions. So when I graph those functions, because they're raised to a power, it's going to look like increasing or a decreasing function. They are sequences that are made by multiplying by the same value each time. We call this the common ratio. To find the nth term, a sub n, fill in a1, r, and substitute in the number for n and solve. So that's what we were doing. We're using this explicit formula. Okay, so let's head. Silver's going to stop, going to do your homework. You're going to attach it into Google Classroom and submit it to me. And I will go over it in the meet tomorrow. All right, so gold, let's head here. Let's see what you got. So you have 100, 60, 36, and 21.6. So how do I get from 100 to 60? So I'm going to do some dividing. See what I get. I get 0.6. So 100 times 0.6 gives me 60. 60 times 0.6 gives me 36. 36 times 0.6 gives me 21.6. So my pattern is that I'm timesing by 0.6. So that's my R. What is my a sub 1? It's 100. My explicit formula is a sub n equals 100 times 0.6 to the n minus 1 power. Find the 12th term. So I'm going to do 100, 0.6, 12 minus 1, which is really 11th power. So I'm going to use my calculator, 100 times 0.6 in parentheses, caret, and then I'm going to raise it to the 11th power. And I get this really tiny number. So I get 0.3627977056. I'm actually going to try and change that into a fraction, see if it comes out anything pretty. I'm going to hit the math button, and I'm going to hit choice 1, which is arrow frac. And nope, won't change it for me. It doesn't come out to be a nice number. So I'm just going to leave it as a decimal like that and call it a day. Okay, so this is the end of the day 1 of the sequences. Stop it here, work on your homework, turn it into Google Classroom. Have a great day.